Hello everyone, this is Dinesh Haldar. I'll give you a small introduction about myself. I have done my MSc from the IIT Dhanbad. After that, I'm teaching the JEE and NEET, okay, both the physics as well as mathematics. I have total 8 years of experience in this field of NEET and IIT JEE competitive, okay. So today we will be talking about a small topic which is the Newton's second law, okay, and this topic from your class 8, okay, from the class 8 only, okay, this is not for 6 or 7, okay, this is the topic I chose from the class 8 standard, okay. So we will be talking about this Newton's second law, right? So first we will be talking why is the Newton's second law, right? Okay, what is actually the second law? So second law says that if we want to push something, right, okay, it will move, right? Correct only, no? So whenever, see, we are not talking about the friction right now. There is a concept of friction which is always oppose the motion, right? But right now we are not talking about that, okay? So here we are neglecting the friction or any other kind of resistance, okay? So whenever we move, we apply force, right, okay? So what happens? It move only, right? The harder we push, right, okay, faster it will move. Example I'll give you, okay. Suppose if you want to ride the bicycle, right, okay. So cycle you say basically, okay. So when we ride the cycle, right, okay. So the harder you pedal, right, the faster you go, right. That means what? You are applying more forces, so obviously your speed also increasing, right? So these are the concept we are getting from the Newton second law. This is a real life example. Another example also we will see, okay. Suppose in case of playing the cricket, right, okay, when we play the cricket, so when you hit the ball, no, okay, if you play the cricket, so you know that if you hit the ball, so the harder you hit a ball, right, so further it will fly, right, okay, it will fly long distance, right. So all are what? All are about the force only, right? How much force you are applying, how harder you are applying, okay? And that first it is moving, right? So these are the example we have, okay? And these are the things we basically get from the Newton second law, right? Okay? So Newton second law basically help us, okay, to calculate how an object moves when force is applied, okay. So in short, what will say, okay, what will say then? Newton's second law, what it do? Okay, it help us, okay, it help us to calculate, okay, it help us to calculate, okay, how an object, okay, how an object moves, okay, how an object move, okay, when force is applied, okay, when force is applied. Understood? Okay. So this is the concept we get from the Newton second law, right? Now we will be talking about the mathematical form, right? Okay, which is very important, okay, the mathematical form of Newton second law. So according to the Newton, right, okay, the force we are applying, right, and because of applying force, what is happening? Speed is increasing. Speed is increasing means what? There is a momentum, right? So what is happening? Momentum is changing. You know the momentum, what we write? Momentum basically we write P only, no? And that is we write mass into velocity, right? Okay, mass into velocity, or you can say speed here, okay. So this is your momentum, right? Okay. So if I want to define the Newton, okay, second law, so how we define the applied force, okay? The applied force is directly proportional to, okay, directly proportional to change in momentum, okay, or rate of change of linear momentum, you can say. So I'm writing in vector form. I hope you know the vector form, okay. So the force we are applying here, that is directly proportional to rate of change of linear momentum, right? Okay, so momentum is a vector quantity. So here we need a proportionality constant. So what we do, the proportionality constant basically we write here K only. So the force will be equal to what? K into, okay, del P, right? Del P by del T only, okay? So you can write here K is nothing but a constant only, okay? K is your constant, okay? Now the thing is, here we are talking about the change of momentum, right? So change of momentum in basically what we write? We write the final momentum minus initial momentum, okay? So P2 I'm representing as final momentum and P1 as the initial momentum, right? So in the time interval T2 minus T1. That means how we can apply that. Suppose here we have an object and mass of the object is m, and here, okay, when the mass of the object is m, now at this time suppose the velocity is v1 and the time is t1. Now you applied a force, so obviously the velocity increasing, right? Okay, and you are applying force up to the time t2, right? And again the mass will reach here, and that case suppose velocity v2. Understood? Okay, so initially the object was moving, suppose the uniform motion, you didn't apply the force there, right? We didn't apply the force. Where we are applying force? In between T1 and T2, okay? Here only the force is applied, okay? In this interval only your force is applied, right? Okay, before that it was in uniform motion. Uniform motion means its speed was constant, okay? It was constant only, but now we applied a force. So either the speed is increasing or decreasing. Here I am considering that the speed is increasing only, right? Okay, so force will be equal to what? K. P2 will be equal to what? M into V2, okay, and the P1 will be equal to what then? M into V1. As I told you, the momentum, what we write? Mass into this velocity, right? Okay, divided by T2 minus T1, right? So from here we will get the force, right? Okay, force will be equal to K. M we can take common here, right? Okay, and we can take common from here. So what will get? V2 vector minus V1 vector divided by what? Divided by T2 minus T1. But you know the rate of change of velocity with respect to time only, no, what we call basically acceleration, right? Okay, this is nothing but rate of change of velocity, right? Okay, so rate of change of velocity we called as acceleration. So what we have then? Force will be equal to what then? Force will be equal to K into mass into acceleration. So we define the unit in such a way that K will be 1, right? Okay, so most of the cases, okay, we define the unit such as K should be equal to 1 only, okay. So if the K is 1, then your force will be equal to what then? Force will be equal to mass into acceleration, right? So from here it is clear that the direction of force will be always along the direction of acceleration, right? The force is a vector quantity, correct? Force is a vector quantity, acceleration also a vector only, okay, but the mass is there here. Here we have the mass which is a scalar quantity, okay. So this will be the relation between them. Now if I talk about the unit, right? Okay, if I talk about the unit of this force, so basically what we consider the unit of force, we consider as a Newton, right? So how we get the unit basically? So I will be telling you that, okay. So force we have here mass into acceleration, right? Okay, mass into acceleration, and this unit basically what we write the mass, right? Okay, so mass will be kg, that means 1 kg, and the acceleration is what we write? The acceleration we write, you know, the unit of acceleration is meter per second square, right? Okay, so 1 meter per second square, right? Okay, this is what we write? Kg meters per second square, and this is only we called as Newton, okay. Understood? So 1 kg per 1, okay, if you want you can write 1, otherwise not required also, okay. If you want to write here 1, no problem, you write like this, okay. Okay, so 1 you can say that, okay, 1 kg meter per second square is nothing but 1 Newton, right? So this is our standard unit, okay, international unit only. So this is our SI unit, right? Okay, if you want to define in CGS unit also, you can define that, okay. How we can define the CGS unit then? Okay, CGS unit means, you know, that here basically we talk about the gram, okay, centimeter as well as second only, okay, CGS unit. So here what we'll do then? We will be taking the mass as what? Mass as 1 gram, okay, and you know the acceleration will be what? Centimeter per second square, right? So 1 gram centimeter per second square, this is we called as 1 dyne only. Okay, so this is the Newton and dyne. So Newton is the SI unit. Okay, capital N I'm writing now. In short, it is Newton. Okay, it is the Newton only. So basically for writing the unit, we write like this. We won't write the full form. Okay, we write capital N and dyne only. Okay, so now if we want to write the relationship between these two, right? Okay, the Newton and as well as dyne only, right? So just I will tell you that also, because sometimes it may be required. Okay, so 1 Newton and 1 dyne, right? Okay, understood. So we want to find that, right? Okay, so listen here. So we have here, okay, 1 kg, right? Okay, meter per second square, right? And this is what? This is your 1 Newton, right? But you know that 1 kg is equal to how much gram? I hope you know that 1 kg is equal to 1000 grams. So we can write a 10 power 3 gram. 1 meter is equal to, you know that 100 centimeters. So 10 power 2 centimeter, right? Per second square, because 1 second in CGS and SI, second will be always second only, right? Okay, it won't change, right? So 10 power 3 into 10 power 2, 10 power, you know, power will be added here, right? Okay, 1000 into 100, right? So 10 power 5 we will get here, and we will get grams centimeter seconds. I hope you know that. If you don't know, I'll tell you. If you have like 10 power x into 10 power y, okay, whenever we multiply like this, so what happens? Their power will be added. Okay, that thing's only happening here. If you don't know this, later we will be talking about that. Okay, in your index chapter. Okay, there will be index in maths, we will be talking about that. Okay, so 10 power 5, okay, grams centimeter second square, right? And this only we can write 10 power 5 dyne. Already I told you know grams centimeter per second square is actually what? Dyne only, right? So 1 Newton is equal to what? Then 1 Newton is equal to basically 10 power 5 dyne. Okay, this is the relation between them. Now everyone see here, we have a problem and we will be solving that problem, right? So there is a force, okay, and its force is pulling a cart of mass, right? So there is a cart like this. Okay, read the problem properly. There is a cart like this and is a block only, okay, which is pulling this cart only, no? And what is the mass of the cart? Mass of the cart is, okay, 100 kg, right? And it is pulling like this. So in this direction force is applied, right? Okay, and what is happening? This system is moving with an acceleration, right, at the rate of, means what? Meter per second square is given, no? Meter per second square, or if you want, meter second power minus 2, right? That means there is an acceleration, right? So acceleration is equal to what here? 1.5 meter per second square, right? Understood? So there is a cart, right? Okay, of mass of the cart is equal to what? 100 kg. I wrote that. Acceleration also they given here 1.5 meter per second square, right? Then what you are finding? You are finding the force exerted, right? Okay, so how much force is applied on this cart only, right? So now only I told you applied force will be equal to what? Mass into acceleration, right? Okay, so mass is equal to what here? 100, and the acceleration is equal to 1.5. Okay, and if you multiply here, so how will that multiply? 100 into 15 by 10, and here 10 will cancel, so you will get here 150. What is the unit? Newton, right? Why I am taking Newton? Because all the unit we have, see, kg, meter per second square, all are SI unit, right? Okay, that's why we are taking it as Newton. Okay, so it was the very simple problem. Okay, everyone, now we will be seeing another one problem, right? Okay, see here another one problem. There is an object, right? Okay, and what is the mass of the object? See, whenever you will be doing the problem, right? Okay, you should write each and every data properly. Okay, so mass is there, right? Okay, and what is the mass here? You can write like this. The mass is 10 kg, right? And what is the initial velocity? So as I told you, the initial velocity, if you want to write, you can write v1 also. So initial velocity is 10 meter per second, right? Meter per second inverse, meter second inverse given, you can write meter per second also. We applied a force here, right? Okay, and how long we applied force? We applied a force for 4 seconds. Okay, 4 second only. So here to there we applied a force for 4 second. Mass won't change. If you apply the force also, mass of the object will be remain same. Okay. But what is happening here? Okay. Final speed becoming how much then? Object is giving 2 meter per second speed. That means you applied force in opposite direction, no? Then only the speed will decrease, right? Here what is happening? Speed is decreasing, right? Okay. Or the velocity decreasing. That means your force is what? The force you applied in opposite direction. Obvious, no? Suppose in this direction an object is moving, right? Okay. In this direction the object is moving. If you apply force in same direction, then what will happen? Then your speed will, okay, speed will increase only, no? Okay. Speed will increase, right? Or you can write like this, speed will increase. If we apply force in opposite direction, when we are applying the force in opposite direction, so what will happen? The speed will decrease only, right? Okay. The speed is decreasing, correct? So whenever we apply force opposite direction of motion of an object, so what happens? Its speed decreases. So here also speed decreases, right? Okay. Now we need to find the acceleration as well as the force, right? Okay. So acceleration will be what? The final velocity, okay, v2 final velocity, right? Okay, minus what? Initial velocity and the time gap, right? t2 minus t1, but here the interval is given here 4 seconds only. So time gap I'm writing here t. Okay, everyone. Here they are not giving time from the origin, right? Okay, when it started, they just given this interval, right? So we can take this interval only, right? Okay, that is 4 seconds. So v2 is 2, v1 is your 10 divided by 4, right? Okay, so which will be equal to minus 8 by 4. That means minus 2 meter per second square. So acceleration negative, right? If the acceleration is negative, this is we called as deceleration or retardation, right? Okay, this is basically we called as retardation. Okay, deceleration or retardation. Okay, this is your retardation, or you can say deceleration. Okay, now if I want to find the force, force will be what? Mass into acceleration. Okay, so mass is how much here? Mass is here, I think 10 kg, and the acceleration here, if I put only the magnitude, right? Okay, see, minus we are writing here, no? Minus actually represent the direction, okay, because in which direction your body is moving, opposite direction you are giving the acceleration, okay, and this will be your 10 Newton, right? This is the magnitude, but if you want to take the direction, you should keep one negative here, no problem for that. Okay, so your force will be equal to 20 Newton, okay, which is mass into acceleration. Okay, everyone, so today's class we are going to finish here only. Later we will be talking about more advanced things. Okay, so today we are seeing up to here only. Okay, there will be many things to learn. Okay, everyone, so keep learning. Thank you everyone.